Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fidaus B.M. Noazman from Group 32. Today I want to present about non-Newtonian rod bump. Okay, let's go for the background part. What is a speed bump? Speed bump is a safety device that is used to slow down the traffic and act as a non-supervised police traffic in the road. What is non-Newtonian fluid? Non-Newtonian fluid is made from cornstarch and water, and the fluid is not obey to Newton's law. This is because the viscosity of the fluid can change toward or can change toward the amount of force. Okay, let's go for problem statement. There are so much complication towards the vehicle during the impact on the speed bump, such as first, damage on the shock absorber. 2. Air pollution increase due to speed bump. 3. Low visibility of the speed bump. And 4. Time delay which cause poor fuel consumption. Our mission and our vision for this project is: first mission is to address problem with traditional speed breaker, reduce damage and prevent accident. Second, to build a long-lasting environmentally beneficially alternative to constraint speed bump. And our vision is to aim to develop manufacturing of the road bump while keeping original purpose of the road bump. And our long-term vision is project will cover all road user in Malaysia, including Peninsular Malaysia, Sabah and Sarawak, the yachts, veterans, and more. Next, for completing our project, we use a literature review. We get a 3 literature review. First, we use from Grant L. Barber, Scott Broughton, and Braham Hicks. They of 3%, they have 3 different patterns and 3 different way they use the speed bump. Grant L. Barber elongated seal chamber with fluid inside in the housing, but Scott Broughton used a plastic as a white low while maintaining durability, and Graham Hicks used valve inside wall of deflection and reinflation. These 3 literature review is very good for our project and for developing our concept. After that, we must know a customer needs to do this project, to completing this project. How we get the customer needs? We get from survey. After the survey, we can do the house of quality. In house of quality, we got a rooftop, middle, right hand side, and left hand side. Rooftop is a correlation for the engineering requirements such as strength, shape, and pressure. In the middle is correlation to engineering requirement and customer requirement. How we get customer requirement? We get from survey. And left hand side is our competitor, is from Nova. And the bottom is technical importer rating to our produce out of or we get the relative weight of our product compared by the competitor. Next is concept sketching. From a three pattern, we do a 3 concept sketching: concept A, concept B, and concept C, which is all of these concepts have a different sizing, different material, and different type of work. Let's go for the concept screening. Concept screening is used for screening to see what the best concept we can proceed to concept scoring. In section criteria, we use for customer needs such as portable, high durability, long lasting, and road safety element. In the head of the table, we get a concept A, concept B, concept C, and concept D. Concept D is our competitor as references to our concept. Okay, for the net score, we can see the concept A get 3, concept B get -2, concept C -3, and concept D get 2. So we can ranking this concept by concept A get number 1, number 2, number 3 for concept B and concept D, and number C, and number 3, and number 4 we get for concept C. From this concept screening, we can choose or we can do an option to continue the concept or not. For our team, we decided to continue concept A, concept B, and concept D. After we continue the concept, we must do a concept scoring. Concept scoring is a little bit same as the concept screening, but is have a little bit different is for ranking, because this concept scoring can use for our development of the concept. In the left hand side, we get a selection criteria from a customer needs, also same as the concept scoring. We have weight, and for each concept we have a rating and weight score. Okay, for this concept scoring, we get a total score and rank. For the rank, concept A get number 1, number 2, and number 3 are for concept B and concept D. For of that, we must continue or develop concept A as our concept for our product based on the customer needs, time, money, and environmental sustainability. 3D design. After we design or we decide to use a concept A as our concept development, we made the 3D design. 3D design, you can see we have a bowl, base, and the yellow one is outer shell, but we can see the inside. So let's go, we see the simulation or animation of this 3D design. For the simulation, we can see disassemble and assemble for our design. We get a bowl, nut, base, outer shell, and fruit packaging. Okay, let's go for exploded drawing. We can see as 6 part of our component is base, fruit packaging, outer shell, nut, bowl, and base. And after that, our team used to build a sort of material to know what the best material, description, and quantity of the product. From the bit of tutorial, we can total up, round up the price per unit for our part. And from the material, we can know the material also have all of our part is used fiber reinforced plastic, which is this material is good for reliability, strength, and also eco-friendly. Design for environment. Design for environment is important for our team for develop this project. Because of that, we use a product life cycle closed loop. Is material, is the main character, material selection, production or manufacturing, distribution, use, and disposal. And this cycle is keep in the cycle because it's closed loop cycle. These are 4 important points for DFE, design for environmental processing and manufacturing, design for environmental, design for efficiency, design for disposal or reuse. After that, we use life cycle assessment or LCA. It's a several step in LCA analysis. We just prepare proposed design option, identify life cycle, identify all material and energy sources, identify output and waste streams, quantify impact of each material and energy, and aggregate impact into categories for comparison. In conclusion, we have developed a solution to adapt the road bump while changing the material without compromising its safety. This is indicate that while we continue to refine the process for making road bump and we maintaining their original function. That's all for me. I'm Fidos B. M. Azman from Group 32. Thank you.